Hey, Optimus Power. Welcome back to me in video form. Today, I had y'all do pages 49 through 52, some classes, and 49 and 52 in my afternoon when I realized that was way too many pages. I'm going to do pages 49 and 52 on this video, just so you can see it done all the way out. You should work along in your module while you're doing this. And if you have any questions, I get to work at 7:30 a.m. Right? You can ask me then, or you can ask me after school, or on Thursday, or before school on Friday. Cool. All right. The first two give me factored form. They ask me a bunch of stuff about my graph, and then they ask me to graph it. In factored form, so in this orange form, I know the x-intercepts right off the bat. The factors, -1 and +3, give me the x-intercepts, which are +1 and -3. It is the flipped version, and I remember that it's flipped because I know that anything that's in parentheses in the equation will be flipped when I find the actual point. My x-intercept then is 1, 0, and -3, 0. So I'm going to go ahead and graph those 2 points. Now I want to change this to standard form. The way I do this is I multiply x times x, x times 3, -1 times x, and -1 times 3. Get these numbers. Then I clean it up, and by that I mean 3x minus x is positive 2x. This is my standard form, and right away from my standard form, I can tell you my y-intercept. It's always the last number on the standard form. Then I can go ahead and plug that number in as well. Perfect. To find vertex form, which is how I'm going to find my vertex, I prep my pattern. I know there's no number out front. There's no a term, so I'm not going to have an a term out here. So I know I just need to find my h and my k, how far left and right, and how far up and down I moved. With the picture, I know I want a perfect square for vertex form and only for vertex form. I've got two x's, so one needs to be on each side. That means x plus 1 and x plus 1 must have been my side lengths. I know that if this were a perfect square, I'd have 1 times 1 is 1 right here. But turns out it's not a perfect square. I'm smaller by 4. And my side length is plus 1. So again, I used my side length to get the inside here, and I used the difference between my C term and my ideal term going in this direction, actually. Saying if I started at 1 and wanted to end at -3, I need to go down by 4. Which tells me that my vertex is -1, -4, because the -1 is in parentheses. I flip its sign. The -4 is not in parentheses, so I don't flip its sign. The line of symmetry is always x equals some number, where the number is the x of the x coordinate of the vertex. Because this is a line of symmetry, I can mirror this green point over on the other side, and I can graph my function. I can also graph this all the way from vertex form by going over 1, up 1, over 2, up 4. Let's do that again. If I'm given vertex form, if I'm given factored form, the very first thing I do is I fill in my x-intercepts based on my two factors, switching the signs. Now over to the side, I multiply everything out to get standard form. I'm going to do the 2 distributed into just the first factor. And now I'm going to do 2x times x, 2x times -6, -4 times x, and -4 times -6, cleaning up the middle by combining like terms, and immediately writing down that my y-intercept is 0, positive 24 from standard form. Now I want to try to complete the square. I'm making perfect squares, and this number out front tells me that I'm making 2 of them, because I had 2x squareds, which are both perfect squares. I'm going to split up the -16 between all these 4 x locations. So to split that up evenly, I need -4 in each of them. This means I would have used 16 in the first perfect square and 16 in the next perfect square for a total of 32. So if I have 32, but I want positive 24, I needed to go down by some number, and that number is down by 8. 32 minus 8 is 24. My side lengths are x minus 4, and I've got 2 blocks. So I think my vertex form should be 2, then the number of blocks, times x minus 4 squared, that's the side length of both of these squares, minus 8, that's how far off I am from my total and from the C of my standard form. From vertex form, I get that 4, -8 is my vertex. I get that my line of symmetry is x equals 4, and I'm ready to graph. I'm going to count by 2s, and I think that probably still won't be enough. I'm going to count by 4s. Count by 4. So my x-intercepts are going to be halfway between 0 and 4 and halfway between 4 and 8. My y-intercept is going to be 24, so 4, 8, 12, 16, 20, 24. I'm going to go ahead and put this on the other side as well. The other side of what will end up being my axis of symmetry. This is 4, -8. My axis of symmetry being 4, and going here. We probably could have counted by 2s, honestly. But either way, you're just going to plot these points, connect the dots, get a parabola. All right, so when we start with factored form, the first thing we do is make it into standard form, and then change it into vertex form. If we start in standard form, I am going to immediately write down my y-intercept, which is this number on the back, before I do anything. It asks for my factored form, so let's do it. I've got a number up front. I've got an a term of 2. If I were lucky, all 3 of these would divide by 2, and I would get the factor as normal. And I am lucky. So we get 2x squared minus 6x plus 8. This is just I divided every single term by 2 and left the 2 out front. And now I get to factor what's in parentheses like normal, quote unquote like normal, which is I'm trying to find 2 things which add to -6 and multiply to positive 8. Based on this, I now know my x-intercepts. My vertical stretch is 2. You might notice that we've got a 2 out front on all these equations. This is where my vertical stretch comes from. And then so this is my factored form as well. My vertex and my line of symmetry still come from completing the square here, so let's complete the square. I have 2 blocks that I'm looking at because I've got 2x squareds. I'll put one here and one here. I'm looking to split up -12x between these 4 locations. So I'm going to put -3x in each of these. Meaning perfect squares then would have a 9 in both corners for a total of 18. 18 blocks used. The difference between 18 and 16 is 2, and we're going down. So I think that the vertex form is 2 blocks of size x minus 3 times x minus 3, and we were 2 over, so we need to bring it down by 2. Meaning my vertex is positive 3, negative 2, and my line of symmetry is x equals 3. Graph. We plot these points. So 0, 16, let's count by 2's. 0, 16 is 2, 4, 6, 8, 10, 2, 4, 6. My intercepts are 2 and 4, so if we're counting by 2's, they're right here. My vertex is 3, negative 2, right here. And we can connect these dots. Let's do another. Whew, this is going to be a doozy. The very first thing, hold on a second.